Hello, guys. Yeah, so we have about 29 people on. Okay, I think we have about 30 people on the live stream. Please, please try and share. With anyone who might be interested. Um, in seeing this, you know, this live stream. Yeah. So today a we'll be doing something really interesting where we pick four questions and I'll just, talk through them, solve them. And, you know, we just solve them and we see how that goes, right? So we'll be solving some questions from NeetCode. So I don't know if my screen is quite um, zoomed in. So we'll be starting in the next 1 minute. Whoa, okay. So let me see. My screen is quite. Pause this. Also streaming this on YouTube, so I'm just trying to set up in every place. Okay, so I think I'm okay. So I'll start the first one, which is the first question which I've picked. So um, before before I go on, guys, please feel free to ask your questions in the chat. Whatever, just drop your questions, and I'll try my possible best to answer them. I do not have a moderator who helps me, with my setup. So from time to time, I would, you know, look at my chat and try to respond to your questions. Yeah. So um, the four lead code problems we'll be attempting today or we'll be solving today is the first one is contains duplicates. Second one is valid anagram. And because my friend Captain said, I should touch on what's it called? He said I should touch on twosome. I think he made a tweet. So I will also be, touching on twosome. So let me just write this down. So the problems for today. The first one is contains duplicates. The second one would be, I think I picked valid anagram. So I have valid, I cannot spell today, okay, anagram. The third one is now going to be twosomes because my friend Captain on X, requested for twosomes. So I'll go with twosome. And the last one is going to, if we have enough time, because I want to keep this stream to, maximum of less than an hour, or let's say an hour. So for that reason, I would add, I'll add, what's it called? Group anagrams. So group anagram. All right. So, I'm doing this in Rust. If you do not understand Rust, it's something that, whatever it is that I'm going to be teaching here today is a concept you can still apply in other languages, right? It's not just for Rust alone. It's something you can take to other languages, apply them, and all that, right? So it's not like because I'm using Rust, so for that reason, you will not find value in this. No, that's not the case. You will definitely find value in this. And please let me know if you can hear me in the comment section, how my voice sounds and everything. All right. So what I'll be doing is, since I've said we'll be touching on, we'll try to, solve four of these questions. So I would get the questions from NeetCode, and the reason I'm solving it here is because I just want like a, let's say something close to, let's say, a notepad or text, like something that does not have much of, let's say, um, you know, what's this called again? Is it autocomplete and all that, right? So I use, most times I use the Rust playground to, write this thing, and, I don't need any setup. I don't have to do any setup and stuff like that. So I can just, get started immediately. Yeah, there are advantages to, using, what's it called? Lead code to do this, but nah, I don't want to use lead code. So I'll get the question. I think I've already okay, I've been talking for like 4 minutes. So I'll paste it here and we'll go over this question, right? So I'll just comment this out and let me minimize. I think I don't know if this is good enough. Okay. So I'm minimizing this. So we'll go over the question here. So first of all, the question says the first question, which is finding a duplicate. So the question says, given an integer of array of numbers, return true if any value appears at least twice in the array, and return false if every element is distinct. Okay, so and when you look at the the question, this one is quite easy, right? So it's basically saying if we have a duplicate. So for instance, in this case where we have like 1, 2, 3, if we find one again, we know we have a duplicate, right? Um, so in that case, we'll return true, right? Then um, this is basically the explanation. Then we have the example 2. This will return false because there are no duplicates. Then I don't think we need example 3. And I also take out the explanations because we kind of understand them without the explanations. We just need only 2 examples. The reason I'm doing this is I'll be able to have enough space on my screen. I'll also delete, and also I don't know if I don't need this. So I'll split this into 2 and I'll add. All right. So this is our this is what we have, right? So this is the question. We are given an integer that contains we are given an array that contains integers. So we're supposed to return true if any value appears at least twice in the array, and we're supposed to return false if that is not the case. So the first way to think about this is there are 2 ways you can solve this. You can go there's the brute force way, which you can ultimately suggest maybe an interview or something where we can say, okay, would sort the array. And the moment we start talking about like sorting the array, we already, there's already an overhead there, right? So we can say we'll sort the array, and after sorting the array, we'll now like have double nested for loops, where, so for instance, how that will work is, let's say we have like this particular guy. So we have this particular guy, right? So if we are using the double nested loop format, what that will mean is would have the first loop would check for the first element, while the second loop will run through the rest of the element to look for duplicates, right? So what that means is when we are at, let's say, the index of I, the nested for loop will then be at the index of I plus 1, right? So the inner for loop would run through the the integers in the array. So it will run through 2, 3, and 1, looking for a duplicate, something like that. So we could do that, or we could go with a more efficient solution. And this will now take us back to set theory. This is something I can find in other languages, like let's say JavaScript, but in Rust we have something we call hash sets, right? So how I would solve this is first of all, I will not solve the brute force style or the brute force way, because we don't have enough time, right? And I think we're already 8 minutes into 8 o'clock here in Nigeria. I know most of the people watching this video are in Nigeria, so it doesn't even matter. But then I'll just go ahead and solve the optimal solution. But ideally, I think the best way to go about this is if you find yourself in an interview, you should always talk about the brute force if you know how to solve the brute force, and then come up with an optimized solution. Also, one thing again, if you're Nigerian, the whole there might be times when my video might go off and stuff like that. I don't want to go into that embarrassing conversation, but when that happens, just bear with me. I would always come back on the stream. But then let's just go into it. So for this, we are going to solve it using sets, right? And I think most of the problems I might be having in this one might come from the Rust mechanics, getting the right syntax and stuff like that. But I think I've already spoken too much, so let me just go ahead and start writing the code. So the first thing I'm going to do is in the Rust, what's it called? In the Rust standard library, we have something we call hash sets. So the way we get hash sets is to say use std. So std stands for standard library. So we'll get into collections. So collections, and then in that place we'll go for hash set, right? So that's basically it, right? So that's like everything we need. So the next thing we are going to do now is to go ahead and first of all, we'll create a function. This is how I like to do mine. So I'll say function. I'll call it contains duplicates. So guys, please feel free to drop a comment. If you have any questions you want to ask, go ahead and ask and all that. But then I'll just say contains dupe. Don't even write too much. So what does this guy take? So first of all, here I would just get this and I'll initialize it in my main function. Say let's or let me just call it array equals to this. So I'm going to be passing it into dupe. All right, so like I said, we're using hash sets for this, so I'm passing the array into this function. So this function now accepts, is expecting something. So I'll say nums, and it's because in Rust you have to define everything that you have to specify the type of everything that you're passing into a function. All right, just like how TypeScript works, JavaScript and all that. Right, Rust is very strict with that. So this is a vector of integer. So it's going to be vec, and it's going to take an I32, right? So the question says we are going to be returning true or false. So in Rust, the function sometimes has to define what it is returning. So in that case, here we'll be returning a boolean. So we'll call it a bool, and that's basically it, right? So now since we are using a hash set, we'll go ahead and okay. So I think I've not explained how hash sets work. So basically, sets they take only unique characters. So when you try to send a duplicate character into that set, it automatically bounces it off and tells you that there is an error and stuff like that. So that's why I'm using sets basically, right? So now I'll go ahead and say I'll call it scene equals to I'll initialize the sets. I'll say hash sets new. Okay, so now that I've initialized my sets, the next thing I have to do is I now have to go ahead and look through the elements in my array, that is the integers in my array. So for that, it's very simple in Rust. So say for num in nums, right? That's basically it, right? So what I want to do is I want to say if I have not seen a particular value, I want to return true. Else, at the end of everything, I just want to return, false. So what that means is, so what I would do here is I would say if, okay, so I'll just do this dot seen dot insert. So if I've not seen, so I want to say insert nums itself. Okay, insert num. Okay. If I want to return true, else outside of this, I just want to return false. So this particular, if I run this code, it's going to break. I'm sure it's going to break. I've already seen like some issues here and there. One of the issues is the fact that whenever you're modifying something like this, like for instance the hash sets, we have to, we have to add we have to tell us that okay, this is going to be something that's going to be mutable, right? So we have to say okay, this is going to be mutable, so we're adding a mute keyword there, right? This is something I've not added just for the purpose of learning and teaching and stuff like that, right? So this is something I've not added. So but for now I'll just go ahead and run this code and see what happens. So I'll run this. Okay, let me set, hold on. I think I need to set this to the side. Yeah, characters. Interesting. Nope. Single orientation vertical. Exactly. So this is how I want it. Okay. So okay, contains duplicates. So mismatched type. We're expecting, so it contains, so here we're basically saying let value contains duplicates. Okay. Nah, that's not it. So line 33. Oh, I see. So the issue here is I forgot to make this a vec. So this is how you make an a vec in in Rust, an array in Rust, right? It's like something like this, or you can do like the vec.new and all that blah 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 stuff like that. But yeah, that's why we are having that first error. Okay, that could be the reason. Cannot borrow as a mutable. Exactly. So this is what I was talking about. Cannot borrow as a mutable. So it goes ahead to say I should add the mute keyword. This is what I was talking about. So I will just go ahead and resolve those two issues, and I'll run this again. So run. Exactly, right? So now you can now see that this automatically gives us true. So if we do something like 1, 2, 3, and 4, and we run this again, it gives us false. So this works. You know, I'm not going to run this on NeetCode because we don't even have enough time. I've spent a lot of time talking and stuff like that about this particular solution. But then we just we'll move over to the next one because I don't have much time and I want to try as much as possible to cover all four of them. So we've done contains duplicate. So say done. So basically what we just did here was, it was very simple, right? I talked about the brute force, but then I went ahead to use the what's it called, the hash sets pattern, right, to solve this. So now that we've solved this, I will just go ahead and move over to the next question, which is valid anagram. So before I get that question, so I'm trying to pull that question from, I usually get it from LeetCode. Then I'll just paste the question here and we'll walk through it. So valid anagrams, copying that question. So this is basically question 242 on LeetCode. So now we are moving over to valid anagrams. And for those that are interested, okay, someone said I should talk about complexity. I don't know what that means. What do you mean by complexity? Can you point out, like, if you can mention the particular complexity you're talking about, then I could, try to talk about them. Or you can just ask a question, right? Any question you have, you can ask and I'll, try to answer it. And like I said, I'm trying to keep this whole stuff as, short as possible. I don't think there is any complex stuff here, aside from the fact that whenever you're mutating, that is, you're inserting, you're deleting. Oh, time and space complexity. Oh, I see. So this is basically an O of N, right? This is an O of N. Thank you for pointing that out. That is something I did not take into consideration, but it's something I would, in my coming video. This was mostly a spontaneous stream. So in my coming videos, I'll focus more on and talk more about that. But the time and space, the space complexity, of course, we're taking some space, right? The set and everything. So it's O of n, right? That's basically what this is. So I don't know if I've answered your question. Thank you so much for raising that up. Yeah. So without wasting much time, I would then go into the next. You know, I'll go to the next question. So I don't know if I should comment this out or okay, let me just comment it out rather than rather than let me just comment this out rather than deleting everything. So the next question here we are going to be, so I'll close this since we're not using it for now. Okay, so with the comments or undo for now. So this particular question, this is for so this is valid anagrams. Then this is contains duplicates for the first one. So I'm just adding it here. So that maybe in the future, if I decide to, split these live streams into separate videos and, upload them, then it makes a lot of sense. So valid anagrams. Okay. So this one says, you're given two strings, S and T, right? Now, return true if T is an anagram of S and false if otherwise. So what an anagram means is, they're basically, words that when you rearrange the alphabet, right? They have the same set of alphabet. I don't know if that makes sense, right? So for instance, you have like, anagram, right? And nagram. So one way or the other, if you rearrange them, some like I think I'm giving the algorithmic explanation of what it means. I could just Google what it means, right? And let me just Google what it means. What's the meaning of an anagram? But I actually know what it means, but just to give a more informed answer, what is an anagram? Okay, so an anagram is a word or a phrase. Let me just copy it and paste it in that place since I'm not sharing my entire screen. So this is basically what an anagram is. So the meaning of an anagram. Okay, so this is it, right? So it's basically the fuck is this? Okay, so it's so fucking long. This is one of the advantages of using something like VS Code and all because it does all those automatic wrapping and stuff for you. But then all the AI and stuff that keeps suggesting to you when you're trying to write code and stuff. So when I try to do like that algorithms, I just prefer to use the playground. But then that aside, so basically an anagram is a word or a phrase made by mixing up letters of another word or phrase, right? So you must use all the original letters in a new order. For example, listing and silent are anagrams of each other, right? So that's exactly what an anagram is, right? So now the question says, we are given two strings, S and T. We have to return true if they are anagrams, or we return false if they are not anagrams. So this is another really interesting one, or let's say simple one or interesting one. So first thing we'll do is say S is going to be, let's call it anagram. So we get this. I'm just trying to set up my, let's say, workspace. I don't know if that makes sense. Anyways, whatever. So let S and let T be equals to something like anagram. And of course, we'll still test for the example that was given to us by Wikipedia, which is silent and listening. Once we are done, coming up with it. So before I forget, like we had two examples, right? So this one is true, and we had rat and car, which came out as false. This one is pretty straightforward to understand, right? So I'll just go ahead and comment out everything so it doesn't break anything when I start, testing the code. So first things first, as always, we'll write our function, right? So call this, let's call it an anagram. Anagram is okay. So No, underscore anagram finder. I'm very bad with names, variable names, and all. So say a function, and I'll call this anagram finder. And this anagram finder takes, according to the question, it's, we are giving it two strings. So we have S, which is going to be a type of, let's say I use a string slice or a string. Let me go with a string, right? So it takes a string, and T that also takes a string. Okay. So as like with our previous example, right? If we're supposed to return a true or a false. So what we are supposed to return is a boolean. So we'll say bool, and that's it. With that, we've like declared our function. So let's not forget that this guy here has to take, S and T. So that's basically it, right? So now the way we would solve this is first of all we have to, so there are a couple of things in Rust that is different from other languages, right? You know, like okay, I would like it's different from other languages, especially when it comes to like syntax. But like I said initially, it's the same. It's basically the same ideology. It's the same, mental model that you apply to, in other languages, right? So you would still find benefits in these videos, with this concept, right? And the idea is the first thing we want to do here is we want to first of all look for a way to, sort these two guys. So when we sort them, we'll then compare them and return a boolean, right? So it's very straightforward. And I, get into the process of, writing the code and stuff. So I could just go ahead and say first things that we have to do is okay, let's look for a way. How are we going to, sort these guys, right? Then we'll go ahead and say compare them. Right, then we'll go ahead and say okay, return a boolean, right? So we could do it that we could. That's exactly how we want to attack this problem, right? So now in Rust, it's completely like okay. Let me just go ahead and and write the code, right? So the first thing I'll do, I'll say let's say s char something like that, and I would say first thing I want to do is because I want to first of all sort. First thing I would do is I would say I'll say s dot characters, right? So now character s. So what I want to do is that now that I've done that, I now have to, because there's way Rust works, right? So I have to collect those values back into, let's say a vector of string slice, or sorry, a vector of characters or something like that. So I would say collect. But something happens here when I try to do this. In Rust, when we use the collect, right? I think there are three instances of how you should use collect, right? First of all, the variable here has to define the type that you're collecting it into. Rust does not know the type you're collecting it into, right? The second way that we use it is the return value here. So whatever I'm writing here is what this function is expected to return. So since I added boolean here, this function is expected to return a true or false. If I try to return something like an integer or let's say a string, right, it's not going to compile, right? So that's another place where we could use what's it called? Where we could use collect, because at that point, um, the collect sort of infers to the return statement of the function. I don't know if that makes sense, right? I hope I come up with maybe I don't know if we solve like in any other question that we're going to solve, maybe in the future or maybe today or so on and so forth. I would be able to maybe give another example of how that works in practice. But then, um, you know, the point I'm trying to make here is whenever you're using a collect in this kind of instance or in this kind of situation, you have to tell Rust what it has to expect. And in this case, what I'm expecting something like this. I'm expecting something like this. Let's say Since we have like anagram, I want something like this: A, comma, I want sorry, N, comma, and I want something like another A, and it goes on like to spell the entire like anagram, right? So if I continue this, I would have G, I would have R, I would have another A, and I'd have another M, right? This is exactly what chars does for me. So chars is now going to like sort of, split that particular string into characters, right? Then I will now collect them back into a vector. A vector in Rust is like, an array in other languages, something like that, right? So all these things I've been explaining is just to like break down the code I'm writing, right? This is in JavaScript, you don't have to do all this. You don't have to do this, right? You can just, do your whole character stuff, go ahead and even sort on the same line and, move on, right? But then this is how it is in Rust. So I now have to say vec. So I'm expecting a vec of characters, right? So I'll say chars. If I don't do this, this would break, right? So I've done this for, S. I will now go ahead and do this for T. So just copy this whole thing and duplicate it. Yeah, paste this here. I'll call this T char, and I'll change this to T, right? So that's basically it, right? So that's everything. Now, from our previous lesson, I would still like omit something. I don't know how fast this recording is. I would have said, okay, who can tell me, where the bug is and everything, but then we don't have that time because this is 8:30 already, and we still have 2 more questions to go through. But then I'll go ahead, and since I've already done this, so Rust now allows me to be able to sort them directly, right? I think in some other languages you would need to, I don't know how it will be done, but in the case of Rust, like once I've done this, I can now I'm now able to go ahead and sort this array, and it would ideally sort it in alphabetical order, right? Stuffs like that for me. So I can now go ahead and say s underscore char dot sort, and I'll do the same thing for t underscore char dot sort, right? But this would ideally break, right? This would break, and this still apply to the same thing that I spoke about in the previous, question that we solved. And I said, if you're modifying anything in Rust, you're inserting, you're deleting, you always have to you have to tell Rust that, okay, this thing is mutable, right? Because the sort method here, changes this, it changes this, the array of characters or whatever, right? So for that, in order for this to work, we have to add our mute keyword here. And we also have to add our mute keyword here. Don't want to waste much time and all that. So this one is very simple, right? So after we finish doing this, all we have to do is to return a boolean, right? And it's simple. So what we do is we say if s char is equal to t underscore char, so we just want to return. And one thing to note in Rust is when you want to return a value from a function, you don't have to add like the semicolon. Once you add the semicolon, Rust will think that the program is continuing from there. So every time when I'm returning something, I always omit that. If you look at our initial solution, you can see that where I returned true, I had my semicolon, but at the end here when I returned false, I did not have that semicolon. So these are like the little gotchas you need to look out for in the language in case you're someone that you're interested in Rust or you're writing Rust and stuff like that. But if you're coming from a different language like Python or JavaScript where all those things don't matter, then fine, right? So now I'll go ahead and run this code and hope that everything goes well, everything runs fine. So let me run this. Okay, so we have a lot of things breaking. So first, on line 69, we have Anagram. Okay, we did not end it. So it's telling me here that we need to end it with a semicolon. So where is that guy? The fuck just happened? Crap, what have I done? Okay. So so this is the issue here. So I have to add a semicolon here. Okay. Expected string found a string slice. Okay. So I just need to, probably make this to say, okay, to string, right? So I would say process is funny sometimes for real. So I'll say to string, see what happens. Hopefully this lets me go to string. I would have just gone ahead and used like a slice, but so let me try something different. Let me do this. Okay, I think those are the only issues. Yeah, those are the only issues. So I'll close this. So the only changes I made here was adding a semicolon to line 69 because like I said, I needed to add a semicolon. You need to always add your semicolons unless when you're about to return something. And here too, I just needed to make this because these were coming in as slides, and of course they are slices, right? So if I did not want that to be the case, I would have just said maybe something like to string here. I would have added the to string stuff here, or maybe, or another way I would have done that was to say, okay, I will do something like, let's say string dot new, and I will just pass the anagram in that place, right, and equate it to our s. But I didn't do that, so the function was receiving a string slice instead of a string. And I made a tweet about this where I was talking about the two types of the two string types in Rust, and this was basically what I was talking about. Normal string, which is allocated on the heap, and the string slice, which is a view into what is allocated in the heap, right? And both of them, they have like different things. I think the string has like a pointer, it has capacity, it has something else. I've forgotten the third one, but I don't want to go into that. I will make a separate video, talking about, that particular, concept. Guys, once again, please, drop a comment. You can help me, retweet, reshare, and ask questions. I mean, if you have questions, ask them. But then, let me go ahead and run this again and let's see what we get. So I'll run this. And you can see that, we're already getting true here, right? So this is true because, they both are, what's it called? They're anagrams of each other, right? And to show some of the things I mentioned earlier on about, ignoring the use of the mute keyword to tell us that, okay, this particular, this particular value, we are going to mutate it. I'm going to take out the mute, both of them, and we're going to like simulate that. So I'll take out the mute and let's see what the error message gives us. So when I run this, I automatically get an error message, right? And it basically says on line 60, right, which is this here, right, where we are sorting. Remember, I said the sort mutates the schar variable, right? It mutates it. So here it's basically telling us that we cannot borrow as a mutable, right? So it goes ahead to tell you that you should add the mute keyword. This is, number one, that this is basically anytime you're sorting something. I think whenever you're sorting, I've forgotten that, just I think there are a list of them, right? But whenever you're mutating something, you're inserting, you're deleting, you're shifting elements or stuff like that, you need to add the mute keyword, right? So I'll just go ahead and undo that. Then another thing again, I would love to show you guys before we move over to the next question is this stuff that I simulated here. So I would like to like print it so that we can see exactly what I was talking about. So I'll go ahead and I'll say print line, and let me just go ahead and say okay. Let me just pick one. No need to. Let me use one. So I'll say S char. Okay, so when I run this, you can automatically see that this is exactly what I was showing you guys, right? So this is what S chars does for us, right? So when we do that, we then have to collect. We then collected it into what's it called? Into a vector. So this collect is basically taking everything and throwing it into a vector. Yeah. So Rohib, yeah, I get your questions where where we can do a baseline and we should return false early when they are of different lengths. Yeah, of course, that is something that you could do, right? I mean, it's something that you should do. I mean, it's something that you should do, but I didn't do it here. But yeah, thank you for that. That's something that you should ultimately do when you're looking at edge cases for some of these questions. Of course, you do not want to start sorting, or you don't want to start doing all these things I did for so a program that you're trying to check, like let's say you're trying to check like 1 million anagrams, right? So you don't want to do that. So initially, what you have to do is, first of all, you just have to go ahead and check their length, right? If s is not equals to t, if s dot length is not equals to t, and all that, just go ahead and return false. There's no need of running through the entire program again. So thank you for that one. That's something I actually forgot to mention. But yeah, that's basically how you solve an anagram in Rust, right? And these concepts are things that you can take and apply to other languages. It just does not only apply to to Rust as a language. So now we have like extra 20 minutes. I don't know if we'll be able to go into as deep as I want us to go. And for some things, like for two sum is something that it's not really a problem. But then I would have loved to go from the brute force approach of two sum to the optimized solution of two sum. But I will not do that because we don't have enough time, and I want to try and see if I'll be able to cover group anagrams in this live stream, right? Or maybe I would do it in another live stream or something like that. But then I want to try and meet up. But Roquib, thank you so much for that's your question, and I acknowledge that I would have done that. So now we're moving over to the next question. So we'll mark this one as done. So valid. What's happening? Yeah, so this is done. Once again, guys, please help me share this video, like and stuff, right? You can share it, with anyone you think that is going to be interested in seeing it. Okay, so the next question we are going to attempt here is two sums, right? So as usual, I will go and get the equation from what's it called? From NeetCode, and I'll paste it here so we can solve it. Okay. So so this question, this particular question is dedicated to Captain because he personally requested for it, and that's why I decided to add it. But then I don't know. I wanted to do the brute force approach, and then go ahead to like do the the optimized approach. But I will just go ahead and solve the optimized approach. Guys, I'm sorry I'm not going very, very deep in all these things. I'm trying to be as fast as possible because I don't have a lot of time to spend on the live stream today. Anyways, so two sums. So I'll call this two sum. I even forgot to test the the silent stuff I said I was going to test from our definition from Wikipedia, but that one has passed. Anyways, so I'll paste. This is the two sum question here. So let's say you're given an array of integers that is called nums and an integer target, right? So return indices of the two numbers such that they end up such that they add up to the targets. Okay, so I'll cut this into two. It's always too long for my liking. Okay, so you can return the answer in any order. So this is a good one. Return it in any order. So we'll go with, so we have like two examples. So we have example one. We are giving, an integer of arrays, and a target. So ideally, if you already look at this at, when I say face value or I value, you already see that 7 plus 2 already give you 9, right? So what you're supposed to return for this is index of 0 and 1. The explanation, we don't need this explanation. If you need the explanation, you can always go to NeetCode and get the explanation for yourself. But I'm just trying to keep space here. So the second one is what's it called? Okay, so the second one we have a target of 6, and we have 3, 2, and 4. And in this one, you can see that the answer is going to be index of 1 and 2. We don't need the third one. So the one thing to note about this question is that we are asked to assume that we would always get two numbers that matches the target, right? So, first, not make the mistake we made in the past, where like Roku mentioned in the comments, right, where we're supposed to compare the length of the two anagrams before going ahead to um, go through the process of you know sorting and then comparing and doing all those maths. And we don't need to do that in this case because the question automatically assumes that we would always hit a target in our integer of arrays, or arrays. What am I saying? In our array, right, that contains integers. Crap. My goodness, I don't know what I was saying. Anyways, yeah, you get me, right? So we are to assume that we would always find two numbers in the array that would equate our target number, right? All right. So as I always do, I'll start with say this is num. I'll copy this guy, and this is a vector, and our targets is 9, which is an I32, right? So what are we going to call this? Let's just call it toSum. toSum is our function, and this function takes two things. So it takes a nums plural, and it takes targets. Okay, so we'll go ahead and just comment out this bad boy. And I know I said I'm not. I know I said I was not going to. I know I said I was not going to, attempt the brute force. But one thing I'm going to do is I'm going to try as much as I'm going to explain how the brute force was going to work, or how it's going to work. Then I'll just go straight into the optimized solution because, like I said, we don't have time. My plan was to like completely solve this in an hour, and this is already like 8:46. I think we have less than 14 minutes or so to solve all this. Okay, so the brute force approach. Now, if you look at this, let me comment this out first. Or before that, let me just write the function. So I'll say function toSums, so toSum, and this function is expecting two things. So nums, which is a vector of I32s, which is an integer, and let's just call it targets. Just keep it simple. And this target is an I32, an integer. And we are to return a vector of indices, right? So a vector of of indices of the two numbers, right, that match the target. So what that means is, I want you guys to take note of this, right? Because whatever this function is going to return, I am actually deducing it from the equation, right? So I'm supposed to return a vector of indexes, right? So what that means is this is going to be vec I32. I can say I32, or I can say U size, right? The reason I say I could say U size is because in Rust, indexes are actually a type of U size, right? They are a U size type. So it's either I say this takes a U size noun, right? Or when I am writing the code, I go ahead and say when I'm passing the values, let's say index of I and maybe the index of J or whatever, I go ahead and say I as I32. That is converting it from a U size to that is from an index type, which is a U size, to an I32, which is an integer, right? But I'm just going to keep it simple. I'll just say I32, right? So now the brute force approach. How would I approach this in a brute force manner? So if I take this guy and I paste him here, right? So guys, let me drink water, please. I've been talking. Jesus Christ of Nazareth. Okay. So if you look at this array or vector, you know, if you look at it, how do you think we could be able to, look for the two numbers that when you add them, they are equal to 9, right? You can think of it that, okay, what if we have a for loop that, runs independently, right? Starts from index of 1, then another for loop that starts as at the index of, sorry, a for loop that starts at the index of 0, and another for loop that starts at the index of 1, right? The one that starts at the index of 1 is going to be nested inside the parent, the one that starts at the index of 0. So ideally, the first one, right, the first for loop would be at the index of 0, while the second one runs through the entire array. And at that point, at every point, it's, we are doing a certain calculation, right? So we would say, basically, we would say the target, which is, 9, we are going to subtract it from the current value, right? We're going to subtract it from like the target. Sorry, we're going to subtract it from the current value, which is, the one at the index of, you know, 0, right? So what that will do is that it is going to give us a value that we can now use to sort of, compare, right? We can use it to compare and check if, it matches. So I don't know the best way to break this down. I think I should just go ahead and write. Maybe I should just go ahead and write the code. That would make more sense. Okay, so let's just write the code. Let's just write the code, right? Hopefully, it makes more sense when I start writing the code, or maybe what I think, is the brute force. So I'll say brute force. I don't want to write this, but anyway. So, like I said, let's say for I in norms, no. So we'll say 0, because we are looping from like the index of 0, right? So we'll say norms dot length. All right. So now we are looping from that place, but what we want to do is we want to get like complisant value, right? So we want to get the complisant. So we'll say let comp be equal to, so we want to say target minus that particular number at that point that we are currently, that particular first index. So in that case, it's going to be like 2, right? So we'll now say num I in this case. So what this would be is this is going to be, target, which is 9 minus 2, which is going to be equals to, 7 for the first iteration, right? So we now have 7. So what we are now going to do, we are now going to have another nested for loop inside our for loop. So this is a very, very bad, in terms of time and space complexity, this is an ON squared, right? This is not something you want to be doing in an interview, right? So we want to have another, I'm actually very thirsty. God. So we want to have another, what's it called? Another for loop. But this time around, how are we going to, do it? So we'll say, we'll say this is J. And like I said, initially I said like for J in, so we're starting at the index of 1 for the second for loop that is nested inside the initial one. So at this point, I'm going to say I plus 1 norms.length, right? So that's basically it, right? So at this point now, how then do we then determine, or how do we get to know when, we have a number that matches our targets? And that's the tricky part. That's the tricky part, right? And the way we do this is by going ahead to say if the number that is J, that's the inner one, that is the second one, because J is representing the second number in our array. Where is that array itself? This is it. So in this case, right, so if I come here, 2 is going to be I, and 7 is going to be J, right? So the next thing we are going to say if I, which is 2, is equal to comp, which is this guy 7, right? We now want to go ahead and return something. So this is where we now go ahead and want to return the I and the j, because at that point we believe that we've found a value that together matches the target. Okay, let me continue. So I'd say so I just want to return a vec of I and j. So we still have bugs here, right? And it's because of something I mentioned earlier where I said the type of indexes in Rust is they are actually use sizes, so it would error out and shout and scream. But it's good for learning purposes because I'll still come back to it and correct that issue. So I'm supposed to add something like as I32 here, but let me just leave it out so we can look at the error message. So here I'll just go ahead and return a vec, because of course the function expects us to return a vec, right? So I would run this and hopefully everything don't go to hell. Okay. What am I getting? If j. Oh, if it's a 9, where is okay, send these two guys. All right, so found keyword 4. Okay. Like expected. Oh, another silly mistake. So I need to end this with semicolon. What else? Okay, there's nothing like norm is norms. Okay, so I have to update that. So this was a silly mistake from me. And also here, so here norms and norms and norms. Where else? So I think that's like the bulk of all the errors. Yeah, you can already see it, adding plus there, telling me, I have to add S, telling me I have to add S here. Then, but the most important bug here, to take note of is the one I mentioned, right? So you can automatically see that it's already telling us that there's a mismatch of types, right? So Rust is expecting an I32, but found a U size. So this is what I was talking about initially, that indexes are a type of U size in Rust, right? So it now goes ahead to say you can convert a U size to an I32 and panic if the converted value doesn't fit, blah blah blah. It goes ahead to tell you can do a try into, use an unwrap. All those ones are unnecessary. So I'll just go ahead and just do the normal one that I know that works for me, which is as I32 as I32. Right. So hopefully when I run this should work. This should give us okay. Okay, so ascending norms. Are you getting answer? Okay, so well, instead of maybe doing it the way I'm doing it, let me say I do it in a different way where so let's just have a val. I'll call it a val, and this val I would say is mutable, and okay. So I'm trying to understand why we're not getting a value. So I'll say vec vec new. So okay, X this. Interesting. So I'll go ahead and say val dot push, and here I want to push I as an I32 and j as an I32. So at the end of it, I just want to return my val. So Interesting. Okay, I did not add a, yeah, I did not add semicolon. Get argument of two. Fuck that. Okay. Hmm. Let's see what happens. This is quite crazy. Hold on. So I'll say return a vec of I as I32 and J as I32. So sometimes you have the Rust mechanisms that would, really push you. So I don't need the saying I don't need the mute. Hmm, interesting. Okay. So I'm trying to debug to understand why exactly, I'm not getting it. I think I have some comments. Interesting. Okay, guys, thank you so much for the comments, and at the moment we have about 130 people on the on the live stream. Um, I appreciate each and every one of you for coming on this live stream, and it has already exceeded the time that I had already set to to stream and stuff like that, right? But then I cannot tell you guys to I can't tell you guys to leave the call, and I say call. Why am I saying call? To leave the live stream, right? But then I really appreciate each and every one of you. Please help me, like the video, share it, stuffs like that, so that more people can get to you know can get to see the videos and like it. Also, don't forget to like ask me questions in the comments. I'm willing to respond to those questions as much as I can, right? The purpose of this whole thing is for us to to learn. um you know we're all learning at the end of the day, right? I always like to mention in my videos, um right? So anyways, guys, um okay, so back at it, right? So I'm trying to figure out, so basically, I'm at this point, I'm trying to figure out why my code is actually not logging anything or not printing anything for me, right? That's what I'm trying to do at this point. So I'll quickly try and get back at it. So um, okay, just give me a moment. Let me just go through the entire code one at a time. Okay, I think I've seen where the issue is. So the issue is basically because I'm comparing, and this is a very silly mistake, right? So what is happening here is I'm actually comparing. So right now I'm comparing what's it called? Num I. So let's say num I is equal to 2. Remember, we're starting from the index of 0, right? So now I'm now comparing it to 7, right? So that means what is inside the if state, this line will never run. It would never ever run, right? So what that means is even this stuff I added here is of no use, right? I don't even need to do that. I think taking this out and having my previous vec, just my simple vec, always like that, would have still worked, right? Because what I want to do is I want to compare, you know, two values that match, right? So the condition has to be true in order for the return statement to to go ahead to run something like that, right? So now, if I change this, let's say I change this to, let's say, comparing num j. Remember, j starts from you know the index of 1, right? So using this our example, so let me get this guy and put him here. So here we have this guy is I, and 7 is going to be j, right? Let me take it back a little. So 7 is going to be j, right? So now if we change this from num I to num j, so what we are ultimately doing is right now comparing. Remember, when we did our target calculation, so we were saying 9 minus num I, which is 2, gave us 7, right? So at this point, what we're now doing is we're now comparing j, which is 7, to our comp, which is also 7. So that will give us true, and that will enable us to be able to log some value here. So this is why I wasn't able to, like, for a moment it kind of tripped me off, because I didn't realize that I swapped I for j and stuff like that. Things like this happen, right? But then I believe if I should run the code now, everything should work fine. So let me exactly. So now you can see that we now have our values, right? So this is one thing you always have to, like, look out for when you're solving. So this is basically the brute force approach. I didn't believe I'll spend this much time on this. I don't want to call it bullshit, but yeah, but then you know I think you're meant to compare. Yes, thank you, Hillary. Thank you so much, Hillary. Yeah. So you're meant to compare J instead of I. Yeah, that was thank you so much, Hillary. I really appreciate that comment. So that was a mistake that I made, right? I I I don't know, I'll say it's a typographical, I don't know. I mistakenly, did that comparison and I did not check it. But I've already, like, sort of gone ahead to, break down the whole I've gone ahead to break down how you should think about these things ideally, right? And because you basically have like two for loops running, like one running faster than the other, and then doing those calculations and making those checks, and then checking if these two things, if they are the same. So if they are the same, they return true. So at that point, you're now going to go ahead and return the index. So it's quite tricky, right? So, but this is basically how I would go ahead to solve, like, a brute force solution, which is something I don't think I'm going to be doing in an interview, because I will just talk about it and go ahead and try to, solve the optimal solution. So let's try and solve the optimal solution. So I'll comment this out, and I'll say the optimized solution. Okay, so instead of all these things that we did, where we had two functions running and everything, we have an on square, right? What if we sacrifice some space to have an O of n, right? And what this means is we'll then basically use something like a hash map, right? So we can go ahead and say, okay, let's use a hash map, and this hash map is, we're basically going to store we're going to store the number, and the number as the key, and the what's it called, the index as the value, right? We're going to, like, that's basically how we're going to do that. Then we are going to you know we are going to somehow get those values, and use it to. I'm really bad at this explanation stuff. I'm trying my best to get better at explaining things, but you'd immediately see how the hash map, if you understand the internal data structures of how the hash map works, and of course it's the same in every other language, right? Once I think in Python they call it dictionary. In JavaScript it's called an object, right? I don't know what it's called in Go. I'm not very conversant with Go. But the point is, once you understand the underlying workings of how the hash map works, the rest is just the language mechanics and the syntax that you have to overcome, which would then ideally, dedicate or direct how you go ahead to, write the code, right? At the end of the day, it's the same thing, right? Um, Anyways, let's just go ahead and write this. I will not waste much time on this. So we're going to be using a hash map. And how do we declare a hash map? It's similar to how we declare the hash set for our initial solution, which is you know the where we our initial problem, which is, I think, what was it again? What was that problem again that we solved? Contains duplicates, right? So now the first thing we're going to do here is we need to get the hash map from the Cardinal library. So we say use std. Let's see. Hold on. Okay. We'll say use std, and here we'll say collections dot hash map. All right. So that's basically it. So next thing we want to do is just want to go ahead and say let's mute, because we've talked about it. Whenever you're mutating something, you always have to use the mute keyword in Rust, right? So there's no point um, ignoring it just to see the errors and going back to fix it again. So let's just run through this one. So we'll say mute, and I'll call it map, right? And I'll say hash map to initialize a map. So I'll say hash map dot new, similar to how we initialize for set. And that's basically it, right? Now what we have to do at this point, we have to go ahead and say for I in, so this is how you loop in Rust, right? So for I in nonce dot length, right? So this solution is very similar to the previous one, very similar. The only difference is that we are using what's it called, a hash map. So we will not have to like we will not be having like double nested loops, right? That's the only difference. So now what we'll now go ahead to do is just the same thing that we did before, right? I can just even go ahead and copy it. So this calculation here, we need this particular guy. We need him. It's very vital to our solution. So this is where the whole Rust mechanics now comes into play, where we now go ahead to I'll write some code that might not really make sense to you if you don't understand Rust. But then it's still the same concept in every other language, right? The point, what I'm trying to do there is I'm getting the value. I'm using the key to get the value from the map. So I'll explain that. So now, first of all, right, I want to check my map. And if a certain value is not in my map, right, then I want to go ahead and insert that value into my map as well as its index, right? But whenever I find a particular, like the complicent or the comp, right, like I called it, whenever I find it in my map, I want to get it and also get its value and return that value as well as the current index I'm currently on as my answer. So this would make sense when I write the code. So the way we do this in Rust is, for instance, in Rust, if you want to handle a situation whereby you only care about a certain value, you do not care about the error and every other thing, we use something called an if-let, right? So the way it works is you say if let sum, so the sum has to be in capital. Now this sum is what is going to extract the value from the map for us, right? So we'll call that value, in this case, we'll say it is, let's just say it's J, right? For intents and purposes. Now, we want to do map.get, and we want to get the key, a key. So the key here we want to get is, comp. So pass, let's say reference to comp. All right. So now, if this is available in our map, we want to go ahead and return, so we'll say vec to return I, which is the current place that we are currently looping, so the current index that we are currently looking at, and J, which is the value of the one that we have initially added. And I will show you when we add that, right? So we'll just say I and J, right? So Don't forget your semicolon. But if that is not the case, right, we want to skip all this, and this is where we'll now go and do our map.insert. So we'll say map.insert, right? So here we now want to insert nums. We pass in j. No, sorry, I, which is the number itself. So it could be 2, and the index of 2 is going to be 0, which is I itself. Right. So that's basically it. Right. So at the end of the day, we just want to return a vec. I think that's basically it. That's just it, right? It's very simple, right? So we are checking the map. If a particular key is not there, we go ahead to insert it. So we insert it, we insert that particular number and its index in the in our map. Then we go again, we check, okay, is it there? It's not there, we go again, we insert that particular number and the index of that number. When we go again, we check, oh, okay, this particular key is there, right? Okay, return the value of that particular key and give me the current index that I'm currently on, which is I. So we get that particular one that we matched, which is J, and we pass the current index that we're currently on, which is I, and that will give us the answer that we are looking for. It's quite simple, quite straightforward. Okay, I always know that there will always be an issue. Yeah, of course. The whole usize rubbish that I mentioned before. So I'll just go ahead and say as I32 and as I32. Another problem again. What's the issue? I don't understand. Okay, so the reference. Why do I have to dereference J? Oh, yeah. So this is just Rust being Rust, right? So this does not concern you if you don't write Rust, but I need to get a reference to J because I cannot take complete ownership of J from the object, right? From the map, from our hash map, right? So it's either I go ahead and I do this stuff that they are saying I should do here, or I just add a reference check mark there, and let me see what happens. Exactly, and it works, right? So, this is why I didn't want to do the whole two-sum stuff. It's always, two-sum is one kind of question that is not hard, but it has a lot of, gotchas and stuff that, comes with, especially with a language like Rust, where you have to be extremely careful. You have to watch out for little things. And like I always say in my videos, right? This particular concepts that I talk about in my Rust videos and stuff, I try as much as possible to relate them to other languages because Rust was not my first language. I started with JavaScript, and I'm not one person that would diss on other languages because of another language. But yeah, I love Rust, right? I love it so much. But you would hear me once when I'm teaching, I make reference to how things could be applied in other languages, right? So every single thing I've said here, there are things that you can take and you can apply it to languages like Golang, JavaScript. In fact, the map.get is something that you see even the insert is something that you would see in I think for JavaScript, I think it's set also. I've forgotten. I have to look that up. Right. But these things are things that they are similar. And that's why people say once you learn one language, it's easier for you to move on to to learn other languages, right? Anyways, that's it for for two sums. I'll just mark that as done. So for group anagrams, I don't know if I'm going to do that. I don't know, guys. If you want me to do that, please leave a comment. Drop a comment if you want us to do the whole group anagram something. But then I don't think I have the energy to go into that at the moment. Also, let me know what you think about the the live stream so far. Is this something that you guys would love to see me do consistently or repeatedly, or is it something I could just do as a hobby, maybe once in a while, anytime I feel like it, I just jump on the call. Just let me know whatever you think in the comments. I really appreciate. So far we are about 292 people on this live stream. I think this is the largest I've ever had people join my live stream, and I appreciate each and every one of you, each and every one of the 292 of you guys. I'm even taking a screenshot on my phone because I'm currently looking at my Twitter here. I'm looking at my Twitter and how everything is working on my phone, right? I appreciate each and every one of you for coming on my stream and participating and showing love, everything. I really do appreciate. It's not easy, right? Very short on my phone because it's not easy at all. To have 292 human beings. Um, you know. Okay, so two persons said I should go. I should do the last. Kind, I know the pity person. Anyways, like I said initially, I'm a Nigerian and I'm in Nigeria, and I know that the vast majority of the people that watch my videos are Nigerians. So in case everywhere goes dark all of a sudden, you guys should know that the thing that happens has happened. But I would always come back and continue the stream. So I've already had like about three persons say I should continue the whole series. Emmanuel, I don't know why you're laughing, but then I just have to give those disclaimers because you have to use what you have to fight for what you want. That's life. There are no excuses. So I will just go ahead and let's do the final one, which I think is like I feel like it's the most complex. And because in that one I'll be explaining a lot of Rust mechanics, talking about a lot of deep Rust concepts in that one. Um, you know, so I feel like that one might I don't know how it will be, but let me not just talk too much. Let's just get into it. So as usual, I'll go to LeetCode and I'll get the group anagrams. I'll get the question. So as I always do, the first thing is to close this guy. Comment this out. Okay, so oh crap, what's happening? Okay, so I'll comment this out. Comment down. Remove these guys. Okay, so the next one is group anagrams. So I'm just going to take the question and paste it here, and we'll go over it as we usually do. So guys, once again, thank you so much. I think we're about 300 persons. I think this is like the largest I've ever had people come on the live stream, and this is like the largest. I really appreciate you guys. Honestly, I don't even know what to say. Hopefully one day I start getting to the point where I have like 1,000 people on the live stream. That would really make sense. It would really mean a lot. Okay, so for group anagrams, let me get question. So I'll basically call these group anagram, and I'll just paste this here. Okay, so basically what this is saying is giving an array of strings or string slice or whatever. I think this is string slice in Rust or something like that. Maybe. Okay, sorry, strings, strs. Okay, group the anagrams together. Sometimes I mix this whole Rust string stuff with normal language, normal programming language or programming language, grammar or stuffs like that. Because in Rust we have something we call like string slice, right? And it's str that we use to signify it. So you can begin to imagine where the confusion is coming from. But at this point, my brain is already fried. I think we've been streaming for about an hour, let's say an hour, 10 minutes, because I started this stream 15 minutes earlier just to allow people to ease into it and get myself prepared and all that. So I think I've been talking for a while, right? A while now. Anyways, I'll try as much as possible to finish this one as fast as I can. Okay, so given an array of strings, right? And these strings are strs, it's called like that. So group the anagrams together. We already know what anagrams are. If you joined me initially, I explained it. I even went to Wikipedia. I picked up the meaning of anagrams from Wikipedia, and I brought it back here. And we solved the anagram problem. Very easy, straightforward stuff, right? But in this case now we now have an array. No, I don't have I don't have these stuffs on any GitHub repository, right? As you can see, I'm even solving it on Rust playground, right? But if you need it on my GitHub repository, I think I can do that. I might do that. Just send me a DM on X. Remind me. I'll create a public repo and I'll just push it there for anyone that is interested in playing around with this code and stuff. So as I was saying, we have like an so basically we want to group them as an anagram, right? The thing that makes this one sort of a little bit complex is because of what we have to return. And if you write a language like Rust, right, you have to be extremely careful when you're solving this particular problem because there are a lot of things. Um, Thank you. Yeah, I get the joke. So avoiding water, it wasn't the rust and stuff. I get that joke. Thank you so much, guys. I really appreciate you all coming on this live stream. On X, I have about 314 people on the stream. On YouTube, I have about 15 persons. I think this is the largest I've ever had people. But then let me not digress. So as I was saying, we have an input of strings in an array. So we have it, we have t, we have tan, we have it, we have nat, we have bat, right? Bat, Bola Ahmed Tinubu. Interesting. Anyways, um, then we're expecting an output, right, of these anagrams grouped together, right? So if you look at it, we now see that we have like bat, we have nat and tan, and we have it, and t, right? So the explanation is basically saying that there is no string in the strs, that is in the strings, that can be rearranged to format for bats. Exactly. So there is no one that can be arranged to the format of bats. So that's why we have only one in this array. So basically we have arrays that are, we have arrays that are nested in an array, right? So that's why it's called a group anagram. Now, the string nat and tan are anagrams as they can be rearranged to form each other, right? Same thing can be said for, it, and t. They are also anagrams as they can be rearranged to form, each other, right? So one thing I always like to do when I want to solve these problems is, I start to think of, how can I come up with, solutions for this problem, right? How can I come up with a solution for this problem in the most easiest way? How can I add like from previous problems I've solved, get things from here and there and try to come up with a solution? If I was not streaming live, right, I would spend like the first 10 minutes to 15 minutes writing out, just basically typing on my screen to break down the problem in the most basic human form that I will solve it in the real world. This is how I try to solve my own problems. Like when I get this like data structures and algorithm problems like this. And this is something I always advise anyone to like cultivate the habit of doing, which is basically, writing out the most naive possible way that you can solve a problem, right? Don't try to, have it all in your head at once and say, okay, fine, I can. It's always important for you to write some sort of notes. The reason I'm not writing any notes is because this is a live stream and I'm trying to keep it as short as possible, which I've of course I've not been, able to do, right? But then, you have to like take a step back and think of how am I going to solve this, right? How am I going to be able to, solve this problem? And you would see that this particular group anagram, it sort of, brings everything that, I've touched on in different questions and sums them up, in this question and tries to solve them. I think some of the things I've done, right? So without, digressing too much, I'll just go ahead and start writing the code for this. I don't want to waste much time on this one. So I'll call this, first thing I want to do, I'll say, there's a group anagram. Okay. Should I say function anagram? All right. So this first we have an input. So this one we just have an input of only this. We don't. What am I doing? The hell am I doing? The question, right? Okay. So. So I'll put this here. So I don't need a target at this point, just my array of anagrams and whatnot, right? So how do I go ahead to solve this? Now, um, so my function, of course, it takes, what does it take? It takes a, a vector of strings, right? I'll call it a vector. Or should I go with strings or string slice? Let me go with strings. Let me just keep it simple because I don't want overcomplication. So I'll say strs, because that's what the question calls it, right? So I'll copy this, change this from nonce to strs. All right. Now, remember, the output that we are expecting is an array of arrays of, is an array of arrays of strings, right? That's the output that we are expecting. So we have to match that in our return statement in Rust, right? In languages like JavaScript, you don't have to do this. You just go ahead and write whatever you want to write. So, but in Rust, I'll say is a vec with another vec inside that now contains a string. And we'll close it, right? That's basically what we are returning, right, at this point. So I'm going to write very ugly code here. Not ugly, but I'll be using clone in a couple of places, which is something I will ideally not do, but because I don't have much time on my side, I'm trying to like wrap this as fast as possible. I'll go ahead and do it that way. So now we have that. So how am I going to be able to, move through every string or string slice in this array and be able to, sort of sort it, match it, and maybe somehow bring in, what's it called? A map, a hash map in the whole process to help me, keep track of, these values, right? Now, speaking of hash map, right? Hash map is, something that, okay, I'll get back to that, right? So ideally, I'll just take some notes. I'll say the first thing I want to do is, I want to be able to, first of all, have a map. Secondly, I want to loop. Thirdly, I want to, we'll call it get chars and I say sort and compare, probably. No, sort. I have to sort and get chars sort. Yeah, and then at that point, I then want to, get keys and, stuffs like that, right? So how I'll solve this is, first off, I need, as always, I need to get like our hash map. So use std, call it collections dot hash map, right? So I'll just take out distance, blocking my way. So first thing I have to do is I have to initialize my hash map. So I'll say let's mute, as I always say, you have to use the mute keyword because, of course, right? Because of course, okay. What is this person saying in the chat? Interest. A lot of comments here. Okay. So, okay, as I was saying, so I have my map. Right, and here I want to go ahead and define what my map is, my hash map is going to contain. So to contain a key of string, right? And a value of vec that also contains a string. The vec contains a string, right? So that's basically Rust. These are Rust focused stuff, right? If you're using JavaScript, you don't need all these ones. You just go ahead and define an object and move on, right? But then this is Rust. So now, like I said, we want to look through this particular guy, right? So I like to keep it closed so I can always, imitate or imagine things or kind of like draw things and stuff as I write the code and I move through my solution. All right. So the next thing is I want to look through every value here. Okay. I want to look through every value here. So I'll say for I always like using I in 0 dots. So in Rust is 2 dots, right? In some languages with 3 and stuff like that, depending on the language that you're using. In Rust is 2. So we say strings or str, just call it string. Or yeah, string dot length, right? So now we already at this point we're already looking through the everything in this particular guy. So what do we want to do at this point? At this point, right, what we want to achieve is something similar to what we did when we solved the group, sorry, when we solved for anagrams, right? We want to do something like this. We want to do something like this, right? But in order for us to be able to do something like this for every string that is in that array, we now have to look through each and every one of them. And at the point of looking through each and every one of them, we now have to pick one. So we'll pick something like it, right? So we'll pick it. We'll pick it. So let me say what we want to. This is what we want to do. What we want is something like this. So we want to pick something like it, EAT. I cannot teach Rust and teach JavaScript at the same time. Anyways, I'll come back to that. So we have it, and what we want to do is we want to then use something like strsi, because that's strsi is going to give us, it's going to be equals to something like it, right? So what we want to do now is we want to now get some. So let's say I'm just trying to. Right, so we want this. So something like this. We want something like this, where we have E, and also where we have A, and where we have T, right? So we want something like this for every of these letters, sorry, of every of this string. So one same. So when we now move to the next one, so at the index of, because right now, strs or string at index of 0 is pointing to it, right? So string at index of 1 will be pointing to T. So with T, at that point where we have T, we would have something like this. So let's copy this. We'll say we have something like this. So for T, it will be equals to this. So let's say instead of, so we'll have T, E, and A, right? At the index of 1. So it keeps going on like that. Like, so this is what we want for each and every one of them. The purpose for this is that it will now enable us to be able to sort, right? So when we sort, we can then get a key, which will then help us to, group them in our, in our hash map, right? I feel like there's a lot more explanation I'll have to do going down the line. But as I go on, I would, try to break these things down so that, because I think one of the issues with data structure and algorithms, which is something that I also face, is the ability to imagine how things are actually being moved around. And that's why I'm taking my time to like explain these things as in-depth as possible, because it's in the imagination. That's where, like, being able to have that imagination and being able to now see it happen, put it in writing or put it in code. I feel like that's where the actual learning happens, and that is where data structures and algorithms starts to get easy to solve. Right? That's my personal opinion. Right? I don't know how other people do it. Maybe some people say, "Oh, go ahead and cram everything." I don't know, but whatever you must do to succeed, that's fine. But I try my possible best to imagine this, like try to imagine the situations, try to go through the code step by step, try to see what is happening so I can be able to apply it in other questions or new questions and stuff like that, right? So now, in order to do that, I'll just go ahead and this is a raw specific thing. So I've explained it before. I'll not go ahead and explain it again. So I'll say Charles, I'll call it Charles val, and I'll not explain why I'm doing some certain things because I've explained it before, right? I'll still explain, Sha. I'll say vec. Remember, I said whenever we have to determine the particular type that a variable should accept, it should be the case where we're using something like a collect, right? So that's exactly what is happening here. So I know I said I was not going to explain, but then I have to explain. So now I'll say string. So string I. So in this case, we have gotten it at this point. So this is, let's say this is it at this point. So what do we want to do? We want to turn it into this guy. So in order for us to turn it into this guy, we use something called chars, right? So when we call chars, it gives us this guy, right? Then we now have to collect it. It gives us this. Then we have to now collect and do dot collect, right? So we say collect. So this collect now takes everything and puts it into our array. That's why we have this vec chars. So we're putting the characters like this, we are splitting them into individual standing groups. So we're saying this particular guy, EAT, split them into individual characters. That is E as a character of his own, A as a character of his own, T as a character of his own, and take everything there and throw it into an array, right? So that's exactly what we are doing here. So I'll say collect. So this is exactly what we get, right? So now we'll now go ahead and do what? Sort it. Because at this point, we're looking for a key, right? So we'll now say char val dot sort. So we sorted it. So we'll now go ahead and, because we're looking for a key, and this key has to be a string, right? And one thing I did not explain is the fact that now that we've done that, so the next part is the sorting part. So when we sort it, we would now have something like for E, A, T, and T, we would have this. So we'll have something like A, E, T for both of them. That would be the key, right? So that's what we are now trying to achieve in the next line. So we'll now say let key. So let key equals to string, right? So at that point, because we'll still do some kind of collect. So there's something we call into iter. That's like a Rust specific stuff. I'm not going to explain what that means. But basically, it's just converting the whole thing to a string, right? So we'll say char val dot into that's called iter, right? Dot collect. Right? So that's basically it, right? So with these 3 lines of code, we've been able to take one string from our array, split it using the chars, put it back into our vector as individual elements or individual alphabets or values or whatever you want to call it. Then went ahead to sort it and then went ahead to get the key from it. So this is going to play a vital role in what we are going to do next. So sorry about that. All right. So now we're now at the point where we now have to go ahead and check if we have that particular key in our hash map, right? So this is where the hash map now comes into play. So this long complicated line of code I wrote here and everything, right? This is where it now comes into play, where we now have to write a get mute, check if the key is check if the reference of the key is available in the map. If it is, we want to get I would explain, right? Of course, you can use this approach for JavaScript, right? Everything that and that's the good thing about solving these problems. This same approach you can apply it to JavaScript. You can apply it to you can apply it to Go, Lang. I'm already applying it here in Rust. It's just that it's different syntax, right? You can apply it in any language, even Python, right? In JavaScript, the hash map here that I defined on line 136 is a simple object. I think in Python it's like a dictionary. I don't know how they do it in Golang and other languages, but at the end of the day, it's the same thing. Thank you for that question, Annie. Thank you so much. So, so as I was saying, right, at this point now, we are at the point where in our objects, right, let's say this is our object, right, and inside our object we have AET. So let's say we have this AET as our key. Then we want to have something like this. So an array that contains our values, right? Our values. That's what we want to have at this point. So we want to have an array that will contain EAT, that will contain something like, let's say, TEA, right? So whenever we do something like, okay, you're welcome, Annie. You're welcome. So whenever we do something like if let sum, which is something I've used, in the previous solutions that we've done, and whenever I do like an if let sum, at that point, we are basically getting the value of this key because we'll be passing this key as a reference into our map, right, to get it. So I think this will make sense once I start to write the code. So at this point, we'll say if let sum. At this point, I'll use a name that makes sense. I'll say group. So let's say group, right? So I want to get the group. So this group is pointing to our values. So we'll now say is equals to map. Remember, we have our map here, right? So map dot get mute, and we want to pass the reference to our key, right? So that's basically it. So we are saying at this point, we are saying, okay, if this key, right, is available in our map, go ahead and push into the array, which is this group, push that current string into the group. So that's why at this point I'll just go ahead and do something like group, sorry, not there, here. I'll say group dot push, right? So I just want to go ahead and push string, which is this guy. Oh, there's an issue here. I have to declare this as declare what I was expecting here. This is a vector of string. Has to be capital letter. Yes. So I just have to come here and say str s and I. So I want to push this. So like I said, I'm going to write like very ugly code here. So because I'm using strings everywhere, I'm just going to do clone because I don't want Rust or Hala. So, all right. So, like I explained, right, the key here is basically, checking, do we have this key in our map? Do we have this key in our map? Remember, the line of code we have on line 138 is just a simple object, right? It's just like, of course, it's not just a simple object, right? But it's an object like, in JavaScript, how it is. I'm trying to simplify the concept, right? Now, we are basically saying, do we have this key that we've defined here? Do we have it in our map? If so, get it, like get something that we can mutate, right? That's why I'm using get mute. I could actually just use get, but because I want to mutate it, I say get, the mutable one, like, get the mutable value, which is the group. So I want to now do group.push. I'm now pushing the current guy that we are currently looping, right? We are now pushing the current guy that we're currently looping, which is, string.i.clone. So we are pushing that particular guy into this array. So now what happens if, we don't have that key in our objects or in our hash map, right? It's simple, right? If I take it back to our previous solution, so we did something like this, map.insert. It's the same thing, right? So at this point, we want to insert exactly this format of data. So for a situation whereby, okay, there is no key, or where the map is empty, or we are seeing a string for the first time, a particular string for the first time, right? We just want to go ahead and insert it into the hash map. So we say map.insert, right? So we want to say this is where our another place where we now get to use our key, right? So we say key dot comma, not dot, key, and then we'll now pass our our what's it called, that particular value into the array. So this is another place that also helps us to define what our value will look like, because remember, the map always starts as an empty value, right? So at this point, We'll now go ahead and say vec, and I'll say str. So we are passing that strs, which is the current string. So I'll just do dot clone. Like I said, I'll be writing very ugly code here. So don't have strength for Rust and Wahala. All right. So that's basically it, right? So this would come in handy when we have like something like an empty object like this. So we have something like this, right? So there's nothing inside our object at this point, right? Hold on, right? So if this line of code comes and we check, okay, do we have any key inside our object? No, we don't. I'll go ahead, insert a key, and insert an array with that particular string into our array. When we come the next time, we say, okay, we have this key, so there's no need of inserting it again. Just go ahead and push that current string into that same array. So that's how we'll continue, because the if let sum gives us the value of that particular key, right? Which is what I've narrated here, right? So after all is said and done, we now want to basically go ahead to get the values, right? Want to get the values, and all thanks to Ross. Ross has a very easy way for you to get the value. So what you can do is to just go ahead and do map dot into values dot collect, right? So now you might be wondering, okay, Chinedu, why are you not using the whole this stuff here, right? Where you have to declare the type of the type of string or whatever that the collect is going to work on. If you remember, if you joined me earlier on when I was talking about how the collect works, I said it works in two ways, right? When you use it in this sort of situation, you have to always tell us the type, its type. In this case, we did vector chars, right? Taking our previous solution, or I think what we solved in past, I think in the previous anagram question, we also did vec chars, right? You have to always tell it in this situation. You have to always tell it. But another way that you can always also tell it is when when you have something like this, right? No, I don't need this here. When you have something like this and you have to return, right? At this point, it's now the collect now, you know, refers to whatever this function returns. I don't know if that explanation makes sense, right? But like I mentioned, there are three ways. I've forgotten the last one. One is when you use collect in this settings, you have to always define the type to the variable. When you use collect as a return for a function, it would always refer to what that function returns, which in this case is the vec of like array that is or array of arrays that are nested, that has strings inside them, right? So I've tried my best to really break this one down as much as possible. This is something I ideally believe that you can always in your own time, try and solve and take a look at it, whatever, play around with it anyhow you like. But it's pretty much easy once you can sort of be able to, look under the hood, or try to understand the mechanics of how the how these elements and how the code moves things around to solve these problems. I think once you are able to do that, the syntax is the only thing that you have to figure out, and it's just syntax, right? You could make mistake in the syntax, but once you can lock the ideology of how you should solve that problem, it becomes very much easier for you to to attack them, right? So what I'll do is I'll just go ahead and at this point I'll go ahead and try to run this code, and hopefully I will hope that everything works fine. This is Rust, so something might eventually break, and the compiler will start screaming at you and stuff like that. Let me run it, of course. So it says into values, okay. Oh, of course, I'm supposed to add like this is a function, I have to call it. Silly. So okay, what else? Line 166, expected string found, string slice, line 166, 166. Okay. Let me just say, obviously it's not going to force me now to start changing everything to a string slice. Don't get that strength right now, no. Okay. So it's saying expected a string, but let me run this first and see. Clear out this, please. Okay. So the next error that we're having now is just one. So you're saying it's expecting a, so okay, 116. Where is 116? Okay, so this is expected a string but found a string slice. Interesting. Okay, so let me do something. Let me just go ahead and change out a lot of things. Okay. I would also let me just use my string slice because I don't trust this whole arrangement of strings. Okay, let me leave that guy. Key is a string. Go down, go down, go down. So let's run this and see what happens. Okay, yeah. So we still have, but you can already see the solution down here. That's why I prefer my string slice, right? And with that, I don't even have to use the whole clone and rubbish any longer because using clone, it has some memory overhead. Basically in memory you're allocating, you're allocating new space for new values and stuff like that in memory, right? But who cares? This is just trying to solve this thing as fast as possible. Anyways, of course, Ross is already telling me that this is redundant, right? Since I've changed from string to slice, right? So I have to take them out. I have to also take this guy out to just what I was even mentioning before I started reading the error messages. So let me just go ahead and take those guys out. I would have just stuck with my string slice. I was trying to be clever, So take them out. Where else do I have that clone? Okay, I have it here again. So I'll take this guy out. So I would have a clean build out. Interesting. Okay, just push. What the fuck just happened? It's missing an open delimiter. Hold on. Okay, delete this, delete this. Okay. So of course, so we now have like a clean um you know result, a clean result of our our anagrams all grouped in, they are all grouped right together. So we have it, t, and it. They are all anagrams of each other, meaning that if you rearrange them, they will all spell themselves, all the time. Same for tan and nat. Bat is the only one that does not have, an anagram. It's funny because now Bat is a very popular name here in Nigeria for Bola Ahmed Tinubu, the president of Nigeria. If you know, you know. Anyways, guys, so this is basically it, right? We had a little bit of, rough patch here and there. I need to power my laptop. It's actually getting low. Surprising that I've not been charging it since. Crazy. Hold on, guys. Oh my god. Okay. So, you know, so yeah, I planned on staying on this stream for an hour, and I ended up staying for 2 hours 10 minutes. God, this is unhealthy. Anyways, guys, this is the last part of. I think next time I'll just stick to 3 questions, and instead of trying to solve all 4 at once. Uh, Anyways, guys, I think we've come to the ending of this stream, and thank you guys so much for joining. This is the first time I'm having up to 400 people join my live stream, and I'm really happy. I had about 15 people join on YouTube. Thank you all for showing your support in one way or the other. I appreciate the fact that you guys join me on the live stream, and I'll see you guys in the next one. Peace. Have a lovely night.